All right, this is lesson 2, dealing with exponential functions. We're going to be dealing with leading terms and how this changes a little bit, and we're going to be looking at a bacteria situation. Before I do this, though, do me a favor, make sure you pause the video and have some sort of calculator. So if you're watching this on your phone, make sure you have a calculator that goes along with it. So pause the video now, make sure you have a calculator. All right, so what's different in this situation than the pay it forward examples? In this situation, we are going to be starting with more than one. So in the pay it forward situation, we just had one person, tapping two people on the shoulder, and then each one goes from there. Well, in this case, we're going to imagine we take this, and so 0 minutes in, so we initially do this, we are going to be at 25 bacteria. So it's now not the one person. Let's say we get a cut on our finger, you have 25 bacteria cells. It splits every 15 minutes. So every 15 minutes, it splits into 2 more cells. So it doubles. So this goes to 50, and then those 50 double to 100, and then it doubles to 200. So the next now rule for this, because we're doubling, if you notice, times 2, times 2, times 2, our next now rule is still going to be next equals now times 2. Where the function rule changes a little bit, or where we're going to need it, is we're going to use this basic form, a times b to the x. This is our exponential form. We're going to use this throughout the entire unit. And what we're looking at is this. The a is the starting amount. So in this case, it's going to be 25. And then the b to the x is really our next now rule. How much is this changing? Well, it's changing by 2 to the x. Now, if you have a graphing calculator, you can check this pretty simply by just putting in 25 times 2 to the power of x, and go to your table, and you should see it on the table, 25, 50, 100, 200, and so on. When we go to graph this function, we can use up here. So let's go 50, 100, 150, 200. And so this is 0. We'll do 15, 30, 45, 15, 30, 45. And I'll just do the chart that we see up here, 25, 50. So it goes 25, 50, 100, 200, and you see a nice exponential curve. Now, good thing to practice here, 2 things. One, make sure these go up by even amounts. Do not put 25, 50, and so on. Like, you have to put, so each one of these tick marks here has to represent the same amount. So for the distance from here to here, if that's 50, you have to go up by 50s the whole way. You can't do 25 here, 50 here, 100 here, and 2. You have to make sure you do that correctly. We talked about that last time. The other thing to remember is how do we get the rate of change? And a quick reminder with the rate of change. So if we want to get the average rate of change, it's going to be our y2 minus y1 over x2 minus x1, or the change in y over change in x. But if we want to go from 15 to 60 seconds, so at 60 seconds we were at 200, and at 15 seconds we were at 50, and we went from 60 to 15, and this is where the calculator comes in handy. So this becomes 150 up top, and we have 45 on the bottom, and then 150 divided by 45 gives us about an average rate of change of 3.3. And what is that? We're going to get about 3.3 more bacteria per second. We're going to get 150 bacteria in 45 seconds, or about 3.3 every second. Good luck.